Hi everyone, today's lesson is going to cover the topic of derivative of an inverse function. Now, we recently studied derivatives of the inverse trig functions, but we haven't done just derivative of an inverse function, like an inverse of any function. So that's what we're going to cover today. So let's take a look at example 1. And for example 1, I actually just want to start by reading the very first sentence, because the very first sentence covers something that we've already done. So it says, find the slope of the tangent line to the curve f of x. Sorry, we're getting interrupted by the PA.
Again, all juniors, please report to the auditorium. Thank you.
Okay, let's try that again. Find the slope of the tangent line to the curve f of x equals x squared at the point 3, 9. Let me highlight over that because we have done this already. To find the slope of a tangent line at a point, we simply take f of x. So let's bring that down. So f of x is equal to x squared. We're going to take the derivative, which is going to give us the slope of the tangent line anywhere. Power rule tells us that that's 2x. And then we'll plug our point in, 3, 9. We really just need the x value. So the slope of the tangent line when x is 3 is 2 times 3, so the slope of the tangent line at this point is going to be 6. Okay, I'm going to circle that. Okay, now I'm ready to read the second sentence. Now suppose f has an inverse function, which we're going to call g. Find the slope of the tangent line to g at the point 9, 3. Okay, so this is really interesting because you can see our work with inverses from earlier this year. See how the points switch? So x used to be 3 and y used to be 9. This is on f. So we know if g is f's inverse, that the x and the y switch. So you can kind of see that now the x is 9 and the y is 3. So that just confirms that indeed we're working with an inverse. Now, to actually find the inverse, well, let's put this through the inverse machine. And what I'm actually going to do is I'm going to think of f of x for this part. I'm going to think of f of x as being like y. So y equals x squared. Okay? So when we do the inverse equation will be x equals y squared. Okay, so now this is g. This is g. Okay, so we have g. Now we want to find the slope of the tangent line to this at this new point, 9, 3. So there's two ways we can do this. Since y is not solved for, we can use implicit differentiation. So if we go the implicit route, which is probably the easiest route to go, our derivative would be, well, the derivative of x is 1. And the derivative of y squared is 2y dy dx. And so if we solve for dy dx, we divide both sides by 2y. And then to finish this, dy dx, so the slope of the tangent line at the point 9, 3 would be 1 over 2 times the y, which is 3, which is 1 over 6. So I want you to look at that answer. So look at this answer and look at this answer. Do you notice anything? How are they related? I want you to keep that in mind as we work into the second example. Okay, another way you could do this. So this is just kind of piggybacking off of the inverse x equals y squared. Had you not done it implicitly, then what you could have done is taken x equals y squared, and you could have solved for y. To solve for y, we would square root both sides. So y would equal plus or minus root x. Now, this is a piecewise function with the plus or minus, so I'm going to analyze the point where I wanted the slope of the tangent line. So I wanted the point at 9, 3. And as you see, when x is 9 here, our answer would be plus or minus 3, because the square root of 9 is 3. But since this guy right here is a positive 3, I can throw out the minus and just write y equals square root x, because my y is positive here. Okay, now we would have to differentiate this. So remember, y was like our f of x, so now it's like our g of x. So now we have g of x equals the square root of x. Okay, which we know is the same as x to the half. When we take the derivative of g by the power rule, we would get 1/2 x to the negative 1/2, which we can rewrite as 1 over 2 root x. So now g prime of x, well, g prime of our x value, which is 9, g prime of 9 is 1 over 2 root 9. And look at that. 1 over 2 times 3 will also give me a slope of 1/6. So I would say the blue, the implicit, is much faster and easier than sort of solving the equation back for y or g and doing it the traditional power rule way. I would go with implicit for this one, but you're going to get 1/6. Okay? All right, very good. Let's go to example 2 and see if we can't see some similarities. It says, find the slope of the tangent line to the curve f of x equals x cubed at the point 2, 8. So let's start with that. So we'll bring f of x down. So f of x is x cubed. So f prime of x will be 3x squared. And plugging in the x value right here, 2 for x, we're going to do f prime of 2 is 3 times 2 squared. And so f prime of 2 is 12. Let me box that in. Easy. That's what we've been working on. Okay, now suppose f has an inverse function, g. Find the slope of the tangent line to g at the point 8, 2. See how the point flipped around? X and y changed. That's the definition of inverse, so we'll go for it. So we're going to throw our function through the inverse machine, my imaginary inverse machine. And so if we think of f of x as being like y equals, we have y equals x cubed. So if we switch it, we're going to have x equals y cubed, and that's the inverse. Now I want the slope of that inverse at this new point, 8, 2. So let's do it implicitly. Let's go the implicit route. And I think that's the only route I'm going to go, because I think it's going to be way easier. Because if I solve for y, I'm going to have a cubed root, which is going to create x to the third and kind of an ugly looking power rule over here. So I'll just go implicit. So the derivative of x is 1. And the derivative of y cubed is 3y squared dy dx. So dy dx is equal to 1 over 3y squared. And then evaluating dy dx at the point 8, 2. I need only put the 2 in here since my derivative is in terms of y. So 1 over 3 times 2 squared equals 112. Now look at that and look at this. Interesting. So we went up here from a 6 to a 1/6. Now we're going from a 12 to a 112. And I hope you're realizing through just proof by example that it seems that if you find the slope of a tangent line to a function, then the slope of the tangent line to the inverse function is the reciprocal. Not the opposite reciprocal, just the reciprocal, because you can see the sign doesn't change. Okay, so using this sort of rule we just developed intuitively, we're going to do example 3. It says find the slope of the tangent line to the curve f of x equals x to the 5th plus x at the point 1, 2. So I've got my x and my y. So let's bring it down. So f of x from up here is x to the 5th plus x. And f prime of x will be 5x to the 4th plus 1. And so f prime of 1 from up here, my point, is 5 times 1 to the 4th plus 1, which gives me a final answer of 6. 5 plus 1. Okay, now suppose f has an inverse function g. Find g prime of 2. So see what they're doing there? We know that the inverse is notated as g of x. That would be this part. And now we want g prime when x is 2. So the reason x is 2 is because this point flips to 2, 1. And so now my x is 2. So g prime of 2, without doing any work, yippee, is the reciprocal of 6, 1 over 6, and we're done. Okay, let's flip it over. This one says the function f of x equals, let me highlight this. The function f of x equals x cubed plus 2x minus 4 has an inverse function g. Find an equation of the tangent line to the graph of g at the point 8, 2 on g. Okay, well, a couple things. If 8, 2 is on g, then we know that 2, 8 is on f. Just got to kind of assume that there. So what we're going to do is we'll work with f. We'll find the slope of the tangent line to f at the point 2, 8. We'll find the reciprocal. That'll give us the slope of the tangent line on g, and then we'll just write the equation. So a little bit further we have to go here. So here we go. F of x is equal to x cubed plus 2x minus 4. So f prime of x will be 3x squared plus 2. Let's plug our 2 in. F prime of 2, 3 times 2 squared plus 2. So slope of the tangent line when x is 2 on f is 14. Okay, put it through the inverse machine. And when we do that, we get g of x. And the point on g of x that we want to write the equation of the tangent line to is 8, 2. Okay, well, we know that g prime of 8, so the derivative of g when x is 8, when y is 2, is the reciprocal of 14, so we're going to go with 1/14. And that's all we need. Now we have a point and a slope, so we'll just go ahead and write the equation of the tangent line. So 2 will equal 1/14 times 8 plus b. 2 will equal, let's see, what does that reduce to? These are both divisible by 2, so 4/7 plus b. And when I subtract 4/7 from 14/7, I get 10/7. So my final answer, equation of the tangent line to g at the point 8, 2, y equals 1/14 x plus 10/7. All right, and we're on to our very last example here. And I love this example because it brings a prior lesson full circle. So check it out. Find the slope of the tangent line to the curve. G of x equals tan inverse x at the point 1 pi over 4. Okay, now here's why I love this problem. If I go after this problem at a standpoint of this lesson right here, then the work would kind of fall into place like this. So if g of x, right, if g of x is the inverse tangent, then we know that f of x would just be tangent, okay? Because these are inverses of each other. So if g is the inverse, then f of x is the regular tangent of x. So we can get the slope of our inverse by finding the slope of f now at the point. Now our point here would have to switch. It would have to be pi over 4, 1, because here this goes with g. So if you flip the x and the y, then you have what goes with f. And if we find the slope of this tangent line, all we have to do is find the reciprocal, and we'll have the slope of the tangent line at g. And I just want to show here just look at this point with this function. If you would plug this x in for this x, the tangent at pi over 4 most certainly is 1, because if you think about the unit circle, when you go to pi over 4, those coordinates are root 2 over 2, root 2 over 2, and when you find sine divided by cosine, most certainly you get 1. Okay, so from our prior lesson, the derivative of the tangent of x is secant x quantity squared, and I'm going to write it like that because I'm about to plug a point in. Now, if I evaluate f prime at pi over 4, I've got my secant of pi over 4 quantity squared. And when I evaluate that, well, the secant at pi over 4 is the reciprocal of cosine. So cosine is root 2 over 2, so secant is just the reciprocal, 2 over root 2. And when you square that out, 2 squared is 4, root 2 squared is 2, and 4 divided by 2 is 2. So this is the slope of the tangent line to the graph of tan x at the point pi over 4, 1. So I can just now take that, and I've got my answer. So the slope of the tangent line to inverse tan at this point, 1/2. Final answer. And that would be if I go from a standpoint of today's lesson. But let's just hang on a second. Several days ago, we actually learned a formula for the derivative of inverse tan of x. So if you want the slope of the tan line to this curve at this point, you can not go from this standpoint and instead just remember this formula. The derivative with respect to x of the inverse tangent of u was given to be 1 over 1 plus u squared times du dx. And so if my u is just an x, then I'm just going to replace all these u's with x's. So my derivative with respect to x of the tan inverse of x is 1 over 1 plus x squared times the derivative of x, which is just 1. So g prime of x from up above is just 1 over 1 plus x squared. Now, I want to plug my point in that they gave me. Here's my x and y. So g prime of 1 is 1 over 1 plus 1 squared, which is 1/2. See how I get the same answer both ways. So I love this because it just shows two completely different ways to get the same answer. Okay, and the final thought here, it just says that the derivative of a function equals the reciprocal of the derivative of its inverse function. Simple. This is a true statement. We've proven that time and time again by example here, and so hopefully this makes sense. Now the last thing I wanted to do for my visual people, which you guys know I'm visual, what I want to do is show a picture of what you're finding. It's one thing to just be able to do this and go through the motions, but what have you actually shown? Well, let's take a simple function like y equals x squared. Okay, a simple quadratic, and let's graph it. Let's make a table. So if I make a table and I pick some negatives, 0, and some positives, and I feed these in for x, well, negative 2 squared is 4, negative 1 squared is 1, 0 would be 0, 1 would be 1, and 2 would be 4. So if I plot these points, then I have a nice little parent graph of my quadratic family that looks something like this. No big deal. Now what I want to do is go to a point on that line, like maybe I'll go to 2, 4. So 2, 4, right down here, 2, 4. Let's kind of highlight that point at 2, 4. And let's draw a tangent line there. Sketch a tangent line at 2, 4. Well, let's find the slope of that tangent line. Well, if I take y prime, I get 2x. And so if I evaluate the derivative at x equals 2, I get 2 times 2, or 4. So the slope of this red line here is m equals 4. Okay, let's throw our function, y equals x squared, through the inverse machine. Okay, let's take the inverse. So let's do this. Let's graph x equals y squared. See, I flip-flop x and y. That means my table is going to flip. So this table flipped around is going to be 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. So let's go ahead and plot those points. So 4, negative 2 down here, 1, negative 1, 0, 0, 1, 1, and 4, 2. So this parabola has just been flipped. Okay, so there's my inverse. Now, I'm looking for the slope of the tangent line at not 2, 4, but at 4, 2. And so if I draw that tangent line in red, here I am. Well, what will its slope be? Well, if the slope of the tangent line to F was 4, then I know the slope to G is 1/4. So visually, that's all you're doing. Now, one last thought here on this inverse. One way to do it is flip the table like I just did, but also keep in mind, if you solve this for y by square rooting both sides, you would get y equals plus or minus root x. And you can see here, the positive root x is the top half here of the parabola, and the negative root x forms the bottom half. So that's another way you could have known what the graph looked like if you didn't want to make tables and flip them. Okay, so hopefully this all makes sense. This is your lesson on derivative of an inverse function. See you later.